Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own mass coder this side. So welcome to lecture number 26 of the linked list series. Hope you are following the playlist from the starting enough. Okay, now the today's question is flatten a linked list. In this video we're going to discuss this question. So what does the question say? The question says you have a linked list with you, right? You have a linked list with you. Now this linked list is something different, right? So it has two pointers, like it has a data, it is a next pointer, and it is a bottom pointer, right? This one is my next pointer and this one is my bottom pointer, right? Now there are few points mentioned. First of all, the bottom part, that is, this is a treat this as a separate linked list, right? Instead of next it has bottom, right? Bottom pointer, it is also bottom, etc, etc. So this is one of my linked list, this is one of my linked list, this is one of my linked list, this is one of my linked list. Now it has been said in the given, in the highlighted areas, the bottom parts are the bottom parts are sorted. The bottom parts are sorted. As you can see, 5, 7, 8, 30, it is sorted. 10, 20, sorted. 19, 22, 50, sorted. 28, 35, 40, 45, sorted again, right? The bottom parts are sorted. Now, what is the result? I want the result as a single linked list. A single linked list which is sorted. Single linked list which is sorted. That is, my answer would look something like this. So 5, now 5, after that 7, after that 8, after that now 30 or 10, I will choose 10 again. After that it will continue, I'm continuing here. After 10, what will happen? It will go towards 19, then it will go towards 20, then it will go towards 22, then towards 28, then towards 30, then towards 35, then towards 40, then towards 45, and then towards 50. This is my final linked list. Instead of attaching the nodes in the next fashion, we have to attach in the bottom fashion in the answer as well. So 5, bottom is 7, bottom 8, bottom 10, etc. so on and so forth. Right? So this is my input and output scheme. I hope you are comfortable with it. Now, how will you proceed? How will you proceed? So actually I told you the answer in the very beginning only. I said that treat them as simply linked list, as linked list. That this is one of my linked list, this is another linked list, this is another linked list, and this is another linked list, right? So now I can say this is sorted, this is sorted, this is sorted, this is sorted. I have to merge them in such fashion. I have to merge them in such fashion. So is it something like merge k sorted linked list? Is it something like merge k sorted linked list? It is exactly like this. Now what will I do? I will just have to write the code for merge k sorted linked list, but in the starting, instead of these nodes, I have first node as this one, second as this one, third as this one, fourth as this one, right? So what was the algorithm again? So keep reciting with me. What was the algorithm for merge k sorted linked list we discussed? It was something like this. Take a min heap defined by priority queue in the C++, right? Take a min heap, insert all the starting nodes. What are the starting nodes? The circle one, this, 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 this. Insert all the starting node. Insert all starting nodes, right? Next step was create a dummy. Create a dummy and A, right? We know about A, we point A to the dummy to add the nodes. Now, up until my priority queue is not empty, while your priority queue is not empty, what will you do? While your priority queue is not empty, pop the node out, pop the node, add it to the bottom of your answer linked list, to the bottom of your answer linked list, right? And after that, if the popped node, right, the node you just popped out has a bottom, in that case add it to priority queue for further comparisons. Let me tell you that there is no condition given that 5, 10, 19, 28 will be in sorted order always. It is here, but it is not a condition. It can be like 5, 1910. It could have been something like that also, right? So okay, now I hope the clear algorithm is clear, right? Insert all in the start, all the starting nodes, create a dummy and a etc, right, etc. Now what will I do? I will just try to write a pseudocode for you, then I will do the dry run for you, right? So pseudocode will look something like this. First I will create a priority queue. I will not write the whole code for creating a priority queue, right? Let us name it as PQ, right? And make sure to make it as a min heap, comparing the data, Now what will happen? I will say temp equals to head, and now while my temp is not null, pq dot push your temp, pq dot push temp, and temp will move forward. Temp equals to temp next, right? What will happen after that? After this while loop, what will you do? You will create a dummy equals to new node of -1, right? Assign a to dummy, right? Now what will happen? While my priority queue is not empty, what will you do? Node equals to pq dot top, and then pop that element, pq dot pop. What will happen after that? After that you will say a bottom. I will have to assign to the bottom equals to node, a equals to a bottom. Now before removing the connection, you will just do something like this. If node has a bottom, that means this linked list has something to contribute into the answer. In that case, pq dot push node's bottom, node bottom. Now what will you do? You will say a bottom equals to null for further explanation. And after the linked list, after everything is done, what will you do? You will just say head equals to dummy bottom, dummy bottom. Now you can just delete your dummy and you can return the head. You can return the head, right? This is your whole code. This is your actual pseudocode. I guess this is something similar to very much to the code, right? There are no steps left instead of the some basic steps, right? Okay, some basic syntax, right? This is my pseudocode. I hope this is clear to you. Let us look at the dry run and then we will move towards the code. Alright, so here is my input example and let us try to dry run over it, right? So first I will create a dummy node with -1. Let us name it as dummy, right? My A is also here. Now I will put all the nodes, that is 5, 10, 19, 28 into my priority queue. So priority queue will in starting contain something like this: 5, 10, 19, 28. It is already in sorted order, so I will just pop the elements out of from this order, that is 5. Okay, now I will pop that out. I will pop the 5 node. This node has been popped, right? I will assign it to the bottom. Okay, I will assign it to the bottom. A will move here now, and I will just after say I will say that 7 is also here, so I will assign 7. 7 will come in this order because 7 is the shortest among these, right? And now A will break this connection. A will break this connection. This connection is now broken off. Now moving on, 7. I will pop out 7. I will assign it here, and I will move A here. 7 also has a shorter element, so 7 will pop out and it will go to 8. And now after that I will be doing something like this, right? Moving on, what will happen? I will pop out 8 again. 8 will come here, bottom A, and now 8 will give 30, but 30 will come here, right? And then I will break this connection. Now what will happen? I will pop out 10, that is this node. I will pop out 10, I will write 10 here, A will come here, right? The connection will be forming, and then I will push 20. 20 will come something like here, right? 20 will come here, right? Okay, and I will then break this connection as well. Moving on, 19, I will pop out 19, and then I will write 19 here. A will come here, A will come here. Okay, but after 19 I have my bottom here, so I will push 20, so 20 will come after 22, right? So it is 20, 22, 28, 30, right? After 19 I will write 22 here in the linked list, and I will then break the connection. Now I will pop out 20, that is this node, right? 20 will be written here, a will come here, but now 20 doesn't have a bottom, so I will not insert anything into the priority queue. Moving forward, I will pop out 22. Let me continue the linked list here, right? I will write 22 here. I will make a connection. I will move A here. 22 has a lower element. So 22 will be popped out and 50 will be written. 50 will be written, right? And then I will break this connection as well. Moving on, I will pop out 28. That is this node. 28 has a lower node, so it will come between 30 and 50. 35, it will be 35 at the position of 35. Moving on, I will write 28 here, A is here, etc., etc. Then I will pop 30. That is this element. I will write 30. It doesn't have a bottom, so anything will not be inserted into the priority queue. A will move here. Then I will pop out 35. That is this node, and then 35 will be popped out. 35 is here. A here. Make that element. Break the connection. Break this connection after inserting 40. Obviously, after inserting 40, right? Break this connection. And after that, I will be doing something like this. I will be using 40 because 40 is less than 50. 40 will come here. After that, 45 will come here after inserting the priority queue, and at last 50 will come here, right? Some connections will be forming something like this, a, and at 50 last is null. And as you can see, this is my answer. But I will have to do one more step. What is the step? I will say I will assign my head to this, that is head is equal to dummy bottom, and delete this. And now your linked list is 5, 7, 8, 10, 19, 20, 20 to 28, 30, 35, 40, 45, 50. And you can see this is a sorted order, right? Let us now move to the code for it, right? Alright, so here is the coding section, but before moving on to it, I would like to request you to please subscribe to my channel because it really motivates me. I hope you're learning a lot from this playlist. If this is helping you in some way, right, then I'm able to make some contribution to the community I am serving in right now. Now, let us move. So, priority queue, first step, priority queue, then it will contain a node star. So, I will just create something like this because it is a min heap. So, vector of node star, and after that compare node. Let us make a function compare node to compare on the basis of data. Let us name it as pq. First we will have to assign the compare node, so struct compare, and that will be a curly braces here. And now I will say bool operator, and what will it do? It will just take something like this, node star first node is n1 and node star second node is n2, and you can just simply something do like this, return n1 data. Now because this is a min heap, so I will have to use greater than equals to n2 data, right? And then just don't forget to close all the curly braces, right? Let me make the curly brace here also, right? Okay, now what we'll do, I will move forward. I will first create a node star temp which is equals to my head. Let me change the name of the root to head, right? It will be easier to understand, head. Now while my temp is not null, what will you do? Pq dot push temp and move forward, and move forward. The temp equals to temp next. Now what will you do? You will just do something like this. After this, I will just create a new node for dummy. Dummy equals to new. You can assign value, any value to it. Let us assign 1 minus 1. Node star a equals to dummy for the further insertions. And now simply while my priority queue is not empty, that is the nodes are still in there, what will you do? You will pop the node out. So node star node equals to pq dot top and pq dot pop. Next step will be a next equals to node, a equals to a next, and if node has a bottom, in that case pq dot push that bottom, node bottom, right? And now a next is equals to null, a next equals to null. And after that what will you do? You will say head equals to dummy, delete the dummy next, head equals to dummy next, dummy bottom, sorry, dummy bottom. Also here will be a next, a bottom equals to node, and a bottom equals to and here also a bottom is null, right? Sorry for my mistakes. Now you are free to delete your dummy and you can easily run your head, right? Let us try to compile and run it. It should run fine, I guess. Should not give any error. Okay, it is giving some error. What is the error? Okay, oh, I closed it by mistake. Let us try to compile and run it now. Should work fine. Please run fine. Again an error. What is the error? Vector was not declared. Some typing mistakes. Sorry for that. Let us try it now. Okay, running fine. Let us try to submit as well. Hopefully it will get submitted. Okay, it is running and getting submitted. Thank you for watching, right? And please follow the playlist along. And if you like the video, do not forget to subscribe to the channel and like the video. Thank you. Have a nice day. We'll meet again tomorrow.